Good evening to everyone. So today we are going to see a device which harnesses energy from sun. We all know about the solar energy as it is taking the forefront now. So this is one of the device which harnesses energy from the sun and using a method of concentration. So a concentration method is used to maximize the impact of the solar energy thus harnessed, right? So I will share the presentation now. So we are going to see about parabolic trough collector to harness solar thermal energy. So as we all know, a parabolic trough collector is in the shape of a parabola. So you all know that parabola is a shape with eccentricity of 1. They are called as conics. So there are different types of conics. The parabola is a shape with eccentricity of 1, whereas an ellipse is a shape with eccentricity less than 1, and hyperbola is a shape with eccentricity greater than 1. So this eccentricity equal to 1 means distance from focus and the maximum length of this from center is 1. So which means any radiation which is incident on all the parts of this, so radiations which are incident on all the parts of this parabola will be concentrated to one point, which is focus of this parabola. So thus we will get n number of radiation which are incident on the parabola concentrated on one part, thus increasing the intensity of the radiation. So you can imagine this is a parabola here. Sorry. So here you have a parabola. Similarly, you are having n parabolas like this. So the radiations which are incident on all these points will be concentrated on this center. So when a fluid passes through this pipe, right, can be heated using this steam energy, using this heat energy. So if a fluid is converted to steam, right, the high pressure fluid. So if you are having a pump here, you are pumping a high pressure fluid to this inlet. So it is converted to steam. You can direct it to a turbine. So here we are having a solar turbine, right? So this is the basic principle. It can be used for any applications involving hot fluids, right? So what is a parabolic trough collector? It is a type of a solar thermal collector, as we already told. So it has curved mirror which focuses the sunlight on the focus of a parabola. As I already told, it is having n number of parabolas. So all the heat solar radiations which are incident on all these points will be directed to this focus. So anything which passes through this focus will be heated with a high intensity solar radiation, which is a combination of various solar rays which are incident on this parabola, right? Heat transfer fluid inside the tube absorbs and transports heat. And parabolic trough collectors are widely used for concentrated solar power plants. So here we are saying concentrated solar power, which means every solar radiation that is incident on a parabolic trough collector is concentrated on the focus of the parabola. So they provide heat which is used for electricity generation, industrial processes, and desalination. So what are the processes which are happening in a parabolic trough collector? Sunlight concentration. So parabolic mirror which receives sunlight which are incident on the parabolic trough, and it focuses it on to focus where the central receiver which is there, increasing the energy density. Heat transfer fluid, a specialized fluid such as synthetic oil or molten salt, flows through the receiver tube, absorbing and transporting heat to a thermal energy storage or a power generation system consisting of a turbine or any other prime movers. Electricity or heat production. The collected heat is used to produce steam that drives the turbine for electricity generation or directly used for industrial heating purposes and other applications. The key components: a reflector, which is a curved mirror which is in shape of a parabola. That is very important. So a curved mirror should be in the shape of a parabola. Then only the radiations which are all incident on the tube will be focused, and it should be made of high reflectivity materials. So as we all know, any material can either absorb heat. So a material I'm showing in yellow color, which is absorbing heat, and material can transmit heat. So material can transmit heat, or a material can reflect heat. A material can reflect heat. So absorptivity is alpha, transmittivity is tau, and reflectivity is gamma. For any material, this alpha plus tau plus gamma is equal to 1. For instance, a material receives 100 joules of energy, right? Total energy received on the trough is 100. 10 joule is absorbed, right? 80 joule is reflected, and remaining 10 joule is transmitted, right? So the absorptivity is 10 by 100, that is 0.1, and reflectivity is 80 by 100, that is 0.8, and transmittivity, that is the fraction of heat that is transmitted, is again 0.1. So if you add all these three, you should get 1, right? So the reflectivity should be higher. A major portion of energy that is incident on the tube should be reflected. So such type of materials should be chosen, like silvered glass or aluminum. Receiver tube is a vacuum sealed tube which contains heat transfer fluid. So heat transfer fluid should be highly conductive so that it absorbs the heat from concentrated solar radiation and transmits it efficiently. Tracking system, a motorized system that allows parabolic trough to follow sun's movement. We all know sun rises in a direction and sets in another direction. So the movement of sun should be tracked by this tracking system, right? So this is about a parabolic trough collector, which is a highly efficient solar energy system, which is a concentrating solar energy system, which is capable of a highly efficient heat transfer solution, right? Thank you.